In this video, I will explain the meaning of results in internal assessment group for science in IBDP. You know what do I mean by this map? I already explained and introduced it. But here today, I've focused on results. First, we will learn what do we mean by results. And more than that, what's the difference between results and data analysis? Before I start here, we will put numbers into words. Whatever you have found already will be explained and interpreted in words, but which kind of interpretation? Accurately interpret data and explain results using correct scientific reasoning. Scientific reasoning, not your own interpretation. More than that, summarize, briefly describe, explain what the data already presented in tables or graphs in data analysis part you observed during the experiment mean. So in the results, you will explain the meaning of what you have found in graphs and tables. Be very, very careful. Do not make any assumptions. Do not go beyond the data. Whatever you have are the tables and the graphs you prepared. Do not go beyond them. Do not make any more assumptions. You are not going to make a theory. You are going to interpret your own data. The data you have obtained due to an experiment, or maybe the ones you have collected from a database. These are the outlines of what you should do, and I will explain them one by one using examples, okay? First of all, interpret the coefficient of determination. The other is gonna be interpret the meaning of a slope. The other is mention the range of your graphs. I will tell you what do I mean by range. Mention the trend of your graphs, increasing, decreasing, and the shape of the graph. Talk about the outliers. And finally, compare the graphs. If you have more than one graph, you should compare them. This is the outline of what you should do in this part. Okay, take notes, and then I will go to the next slide to explain them in detail one by one using examples. The first is this. Interpret the coefficient of determination. Actually, the coefficient of determination is a number between 0 and 1. You can have a research. There are a lot of resources to explain what do we mean in science by R square, but it's always a number between 0 and 1. And here in this, let's say in scientific language, the larger the R square, the closer it's to 1, means that the better you have selected your best fit line according to the data points. Okay, so coefficient of it could be like that. Coefficient of determination, R square, is larger than 0.9. It's very good number, 0.94, indicating the best fit line was selected as a good estimate of data points. This is the meaning of that. So if you are using a specific spreadsheet like Excel, whatever, try to select the best fit line with larger R square. The larger the R square, the better you have selected your best fit line. Interpret the meaning of a slope. I have a video, I already explained everything about the meaning of a slope. You can watch it in my YouTube channel. But anyway, I will explain it shortly. Let's say we have, let me show you something here. We have a graph like this, a line, and then I'm gonna check the slope. Here I should make a right triangle, and then let's say I realize that the slope of this graph is 5. Means that if this is 1, the vertical is 5. So if you go 1 step forward, you should go 5 steps upward to find the graph. You start from here, go 1 step forward, and then you go vertically 5 steps upward to find the graph again and continue on your line. This is the meaning of a slope. But in physics, in science, the slope has more specific meaning. Here, this is a graph which is explaining force versus current intensity. The force is given like F equals this times I minus this. This is called the vertical intercept. It's not our discussion now. This is the slope. You know, this the linear relationship, and the coefficient of I is the slope. Okay? But the question is that how can I interpret that? The meaning of that is this. First of all, remember you are in science. Vertical is not y-axis. This is force here. Horizontal is not x-axis. This is current here. So when you make your right triangle here, and then you go one step forward, you should go this much upward, 0.0577 upward to find the graph again. This is the meaning of a slope. But one step forward is 1 ampere increasing current, because this is not x-axis, this is current axis. And vertical is the force. So this is the increase you should do to find the graph again in force. So the interpretation of this slope is something like that. For 1 ampere increase in current, the force is increased by this much, the slope. This is the meaning of interpretation of a slope. Specifically, when you have a linear graph, this is a must in IA. I hope you learned it. Anyway, you can watch the meaning of a slope and the concept of a slope in my YouTube channel. I have a video. The other is mention the range of graph. What do I mean by that? Let's say this is the vertical as time and this is the area in an experiment. Forget about the experiment. Anyway, these are some scientific quantities like time and the area, but specifically it has already been found using a specific interesting experiment like that. My student made a parachute, a small parachute, and then she checked the falling time of this parachute according to the area of this canopy. She enlarged the canopy size and then checked the effect of that area on falling time. Okay, this was the experiment, but anyway, it's not that important now. I will tell you that this is a vertical time value here and horizontal is the area. Mention the range of graphs means that the area starts from this value, goes to this. Tell the reader that you know what do you mean by the range of horizontal. Area is changing from here to here. And the time, the falling time, changed from this to this. It's very important. Something like that. Falling time of the parachute starts from 1.4 seconds in canopy area of this, 100, and ends with 3.6 seconds at the canopy area of this. This is the meaning of range. Range means mentioning horizontal and vertical changes you see on your graph. For each graph, if you have more than one graph, you should have a specific interpretation for each. Mention your graphs, the address, the caption of the graph, and then do this interpretation, the meaning of range. Mention the trend of graph. What do I mean by trend? Some graphs are linear, some graphs have best fit line, which is actually a curve, curvilinear, and so forth. Okay, here it's very important that you mention the shape. Also, sometimes you have some fluctuations, okay, a maxima, minima, whatever. Mention everything you see, the visual perspective of the graph. Here, it could be like this. Period of pendulum against angle of deflection has a nonlinear trend. It is increasing and has a parabolic best fit line. You see the best fit line, the period versus the theta, the angle of deflection, is a second order equation. So it seems to be a parabola. So it's a parabolic best fit line. This is how we mention the trend of the graph, increasing, decreasing, linear, nonlinear, and also if that nonlinear graph has a specific name in math, like parabola, hyperbola, whatever, mention them. Sometimes it's very good that also tell the reader that this is increasing or decreasing. Here, my student mentioned it's increasing. Yes, sometimes the graphs are descending. So ascending and descending are different, mention them. It's very important. Tell the reader that you see what's going on here on your graph. As you remember, in data analysis, I mentioned that you should just present your data. You should mention the equation of best fit line, R square, whatever. Now you are explaining the meaning of them. What do you see out of that analysis? Talk about outliers. Outliers are the points which are really off the track. Look at these data points. They are almost all very close to the best fit line. But this one is very crazy. It's totally off the track. Talk about the outlier. Do not interpret that. It's very important. The reason for why should we have an outlier or why could we have an outlier is not here. This kind of interpretation means that mention your results here. What do I mean? Here this outlier happened at this point almost and at this point. So let's say the coordinates. Horizontal, let's say this is force versus current, okay? So we have an outlier at current of 14 amps and the force of almost 50 newtons. This is like that. Mention one or two outliers you have and the specific coordinates of those outliers. And the last is compare the graphs. If you have more than one graph, it's necessary to have a comparison. What do I mean by comparison? There are three factors you should compare. Range. Compare the range. If the range of graphs are similar, mention. If they are not similar, mention. And it's very useful to have a table. The other is appearance. What do you see in appearance? Do they have the same, almost the same appearance, or they are very different? And also the best fit line. Do they have the same, similar best fit lines, or no, very different? For example, one of them may be linear, the other non-linear. If this is so, mention. If both of them are linear, mention. It's very important. So there are three different factors you will mention: range, appearance, and best fit line in comparing the graphs. I'm really thankful to you because I have your attention. This is the end of this video. The next video will be about conclusion, evaluation, and bibliography. See you soon.